All right, we're going to get started here. Hopefully, maybe some other people will trickle in, but we've got a lot of content to cover, so we want to make the best use of the time. Welcome. Really excited to kick off this year's FinTech DevCon. For those of you who have not attended before, it's a fantastic conference. You're in for a treat. You've probably started to look at some of the talks that are given, and they are all full of great content. Last year, I missed out on a lot of sessions because there were just too many to go to and absorb it all. But I think it's appropriate that we start the conference off with a talk on security, because security is the first thing we think of when we start building software, right? It's always top of mind. I'm being a little facetious. We do think that security is a little bit challenging. There's a lot of mistakes that can go into both code and configuration. They're hard to catch sometimes until they're actively exploited. And so what we're trying to do for this workshop is look at some really simple examples of how we can add a defense to a typical web application. I'm Ryan. I'm one of the founders of Jumpwire. This is my co-founder, William. And we've been building web applications for a long, long time. And we love to think about security. Jumpwire is a security product. It's an open source database security suite. This is not a sales pitch, though. We'll talk about Jumpwire halfway through a little bit. We'll get a chance to play with it. But we really kind of want to show some of the tech principles that you can put in place when thinking about how do I secure an application? How do I secure my overall infrastructure? What should I be thinking about when I design security? Just a quick note, if you would like to follow along, I highly encourage you to follow along to the workshop. We have a very detailed README with all the code and diffs and commands that you need to run. It does require a little bit of setup, so if you just go to this repo and start installing some of the dependencies, you will need Docker running locally, and then on top of that, K3D, which will spin up a lightweight Kubernetes cluster, and then a few command line utilities that we're going to use throughout the workshop. And this will let you actually modify the code and reconfigure the cluster to install some of the security appliances and pieces that we're going to work through in the workshop. Probably take you about 10-ish minutes to go through all those steps. So if some of them seem like they're going slowly, you're pulling down all these Docker images, that's fine. Just be patient. It should complete. There's a conference Wi-Fi. It's FT something something. And the password is itshotaf, ITSHOTAF, all lowercase concatenated. So I think the first thing we want to acknowledge is, why do developers care about security? Maybe this is the domain of the security team. Oh, I'm not a security expert, so I shouldn't try to solve security concerns in my app. And we think that this is not really relevant in today's world. First and foremost, the code that you're writing is the attack surface. It is going to be the thing that a lot of attackers or malicious actors are trying to exploit. And you know your code and how your application is set up better than any other one else in the organization. And so that puts you in a really good position to start to put in place fundamentals, to have kind of a mental checklist of what should I be thinking about when I care about security of my application. I think the other thing we've noticed is, attackers are getting smart. They're always trying new attack vectors. And something they are doing more recently is targeting developers. A lot of this is because devs have elevated privileges, like they're able to access systems. They're able to generate secrets or spin up a server or push into production. Circle CI had a really famous hack last year where all of their production secrets got dumped, and it really damaged a lot of their customers because all their customer secrets were potentially exploited. They got in through a developer's laptop, getting malware on an infrastructure engineer's laptop. So you kind of have a target on your back as an engineer today. And lastly, maybe you're working on the back end, maybe you're working on just an internal service or a tool. And these are also vulnerabilities that are being exploited, where attackers are first getting into the private network and then moving laterally across private networks. There's an attack happening right now with a piece of software called Moov. It's a file transfer utility. And so if someone in IT installed Moov into your infrastructure, now that's becoming a thing that's being exploited for an attacker to get into the infrastructure and then start calling internal endpoints or internal tools. So putting security into applications that aren't even exposed directly to the internet is becoming more and more important. So what are we going to do in this workshop? We're going to spin up a microservice architecture in lightweight Kubernetes, and it's going to have an API backend. It's going to have some other jobs that are running a database. And we're going to walk through a few of the categories under OWASP. OWASP is an organization of professionals, some security professionals, security community, and they kind of publish guidelines. In particular, they have this top 10 list where they feel like this is the top 10 most vulnerable parts of an organization today, particularly for applications that are on the internet. So we're going to look at authentication and authorization. This is a kind of really high on their list. We're also going to re-architect our cluster. So we start to add in additional layers of security. Some of the default configurations of common frameworks ship with things that aren't necessarily the most secure or hardened. So we're going to reconfigure some of that. And we're going to try to emphasize like the rationale of why we're putting these things in place, as opposed to the specific tools that we're choosing to use. So we're using Express just because that's a nice, easy API to work with, HTTP API to work with. But we're going to talk about authorization more generally and like why should authentication authorization be in your application. So why are we using OWASP to orient ourselves? We think that it's a nice framework to address kind of common vulnerabilities. Like I said, they source this information from the community, but they also update it on a regular basis. So it's not something that just stays static. So if you look here, broken authentication in 2017 is now called access control because it's not just about authentication, it's authorization. Those are two different things. So they're making this kind of more generic. Cross-site scripting is a very specific attack of web pages, but now they're talking about that as security misconfiguration or insecure design. So they're making this like more relatable to a lot more pieces of of a typical web application stack, rather than just like a server-side rendered HTML that can be exploited in a browser. So we like that it's kind of updated. They take recommendations from the community when they rank these, and we think that it's a really nice framework. It's also something that if you go through a security audit, or if you are regularly getting a penetration test being done on your infrastructure, your auditors and testers are going to check for all these categories as well. So if you can be really well covered here, you're going to get some clean scans and audits. So like I said, we're going to start with something really simple, but it will represent like something that could be a much larger, more complex architecture. So we're going to have an API backend that's serving HTTP requests. They're kind of RESTful HTTP requests. They return JSON. We're going to have a scheduled job that's running, and this is kind of like a background worker or an internal tool. It's not exposed to the internet, but it's sitting inside our cluster. And then we have a database sitting inside our cluster, of course. The API backend is reading and writing to that database. And then we're going to be the front end, our local host. We're going to just use curl, and that's going to represent clients accessing our API servers. This is kind of where we're going to end up. So we're going to add encryption everywhere. We're moving from HTTP to HTTPS. We're going to add authentication. So the API is going to start unauthenticated, and we'll add authentication to it. And then we're going to put in a couple pieces of infrastructure. We're going to put in an API gateway. So that's going to actually sit between a client or the internet and our backend API server. We're going to sample Jumpwire a little bit, just so you can see what a database gateway looks like. And then unlikely we'll get time to monitoring, but that also is in the workshop. And we think it's important that we implement security and we put defenses in place, but you also have a mechanism to see what's happening in your live environment and are there potentially attacks running. So monitoring is the other side of the coin. It's unlikely we're going to get to it in the 80 minutes we have left here. As you're getting everything installed and set up, and again, for people that walked in, there is some dependencies that are necessary to follow along this workshop. Please go to this repo to get locally set up. But we also have a little poll here that we'd like to run. William and I had a little bit of a debate about whether what type of infrastructure people are actually familiar with and using. So it's probably not live yet because I didn't do it. Let me get out of screen mode. So let me turn this on. Should have done that at the beginning. Okay. So if you go to this Slido and enter this code or scan this QR code, we'll check in on this poll. It's mostly about infrastructure platforms, like platforms as a service that you're using. There's some new ones on here like Render and Vercel that are very modern. Some of the old school stuff like Heroku. Hopefully no one's using, don't use Heroku. Right. And at this point, we are going to switch over to the workshop. So the way this is going to work is we're going to kind of go top to bottom of the README. These are some of the setup commands that you will need to run after you install dependencies. We're going to be creating a cluster in K3D. K3D is a Docker wrapper on K3S. K3S is a lightweight installation for Kubernetes. Kubernetes is a way to run applications and have networking and services and deployments. And it's just a pretty common, I'm sure everybody's heard of Kubernetes, I don't need to describe it. So once you have your dependencies installed and you've cloned our repo, you can run this command here. You should just be able to copy it into your terminal. And this is going to set up a cluster. And you'll know it's working if you run k3d cluster list. And there is the workshop cluster running. As we're going through some of the examples, if anyone needs help, if you get stuck, something's not working in your local, please just raise your hand. One of us will come and help you. We think it's useful to actually run through the code yourself. And we're going to try to cover a lot of ground, which means if you are kind of getting stuck, we want to make sure that we can kind of unblock you. We include in our repo a build deploy script. This is going to help you make changes to the code in your local host. So you can pull up in your favorite editor this repo as well. So we can make changes to routes in our Express server. And then to actually get those changes, code changes into the cluster, simply use our build deploy script. And we have two apps that are running. We have the API, which is the Express app backend. And then we have one called Reconciler. This is kind of a cron job. It's a Rust app that is calling our API to do some stuff that you might do in the background. After you've deployed into the cluster, you should be able to get pods in your cluster. And these are the three that you should see. You might not see the reconciler right away. It is on a schedule. It'll run every minute or two. But you'll see a Postgres pod. This is our database. And the API pod, which is running our Express backend. So we're going to dive right in. We've kind of already covered the connectivity. So if you have everything, the API up and running, you can actually test it by port forwarding. So this is going to create a tunnel to our API pod to your local host. And you can issue an HTTP request from your local host to that API pod. This will result in a 404. You might notice in our default route under the index.js, under routes, this is just returning a 404 for slash. We don't have anything at slash. So if you get a 404, that's OK. What you want to see is this X powered by Express. This is a header in the response. And this indicates that your request has hit our Express server, and you're set up and ready to run. So we're going to jump in the deep end. We are going to start by adding a piece of infrastructure called an API gateway. Putting security into the architecture has a lot of benefits. Some of it is that you have a single place that you can put pieces of security concerns, and you don't have to rely on individual microservices running or worrying about security. So like, do you want Express to be vulnerable to a DDoS attack? Like someone decides, I'm just going to throw a bunch of traffic at your Express API and take it down because I'm overwhelming it with traffic. Well, yes, you could hack that into Express, but then when you launch your next Go or Python Django, you're going to need Django to also do request limiting. And so putting an API gateway there just kind of can sit in front of backend applications and handle HTTP in a very consistent way. The internet is a scary place. Anything you're exposing to the internet is going to be tested. And so having a security appliance sit between the internet and everything else in your infrastructure gives you a big advantage. And this is OWASP's second. I think it's their, is it second or fourth? Fourth? It's number 4 on the top 10, but it's a brand new category. And it's really kind of focusing on microservices, cloud architectures. They've become a lot more complex. And so that means there's just more surface area that you need to secure. And having a dedicated piece of infrastructure can give you a lot of help by consolidating a lot of security into one layer. It's not going to do backend logic. It's not going to talk to your database. All this API gateway is going to do is look at HTTP requests and decide, is this something that I should forward onto my backend, or should I reject it right away because maybe something malicious is going to happen? So if you run a kube apply command, this will install an API gateway into your Kubernetes cluster. K3s, which is our lightweight Kubernetes installation, comes with something called Traffic. Traffic is a reverse proxy or an API gateway. It's open source. It seems nice. I've enjoyed using it to put this workshop together. They do put a lot of stuff behind their enterprise version, which is questionable. But it has been very easy to use. And if you ran through the first setup and you hit your Express server with this first curl command, you'll notice we had to port forward. This is how we got traffic from outside the cluster into the cluster. Once you apply our traffic API gateway, you should be able to request the cluster directly without port forwarding to the API. And if we look at what our API gateway is doing, it's defining an entry point and allowing us to match a path to a service. So this is the API service that's running in Kubernetes, and we're saying any request that comes into our gateway that is /API should be forwarded to our API service. And our API service actually is not expecting /API on its paths. It's routing things from root. So we're just going to strip that out before we forward that HTTP request along. And so you could imagine a scenario where you have a versioned API and you're using path versioning. Maybe this is API v1. And when you go to roll out an API v2, how do you start to support running both of those in your same infrastructure? Well, because I have a gateway here, I have an indirection that I can use to route between the version 1 and version 2 of my API, and I'll just point them to different services on my backend. So that's a nice problem that it solves. We're also going to upgrade it, though, to include some rate limiting. So why do we want a rate limit? Well, I said initially there's a potential for DDoS, so someone simply overwhelms my infrastructure by giving lots and lots of requests that my servers can't handle. There's also things called just brute force attacks, like they're trying to break into something, credential stuffing, or just try all these passwords to see if I can guess someone's passwords. They're going to try to do that at a very high rate. And so by doing some simple rate limiting where we say, well, on average, we should only get 100 requests per second by a single IP, and then it should be able to burst up to 50 simultaneous requests. I can start to limit some of that potentially malicious traffic on my gateway. And the gateway is just going to reject that, and my Express server doesn't have to worry about it. So if you apply this diff, we're just going to, again, edit this API gateway chart here for Kubernetes. One note on editing YAML files, the spacing is very important. YAML is white space delimited. So if you get an error whenever you run a kubectl apply that's a bunch of gibberish, it's probably you have a space in your YAML that should be there or shouldn't be there. So I can define this middleware, and I can add an additional middleware to this route. Pretty easy, right? Well, there you go. Nope, missed a plus. There it is. So yeah, I shouldn't have. There we go. So now I've created a new middleware, and I've applied that to my API ingress, which is my gateway. Not too hard. Traffic comes with a lot of other middlewares. They actually have some plugins, but you could do authentication in your API gateway. You could do something like a web application firewall, a WAF, where you're actually looking, is someone sending me SQL in a request? That might be an SQL injection attack. Or it contains JavaScript. Maybe it's some type of scripting attack. You can actually filter out all of those types of malicious requests coming into your HTTP, coming through HTTP through an API gateway. So putting that gateway in place has already increased the security of our overall cluster. If you'd like to see what traffic is doing, it has a pod that is running in Kubernetes. It is in the kube-systems namespace, so when you get the pods, you just need to make sure you address that namespace. And you can port forward directly to its pod to pull up this nice dashboard. It's going to tell you all the routers and the middlewares that have been successfully installed. There's some observability that's built into traffic as well. Great. Now we have our gateway working. We're going to come back to it later on as we put more security defenses in there. But let's look at access controls. So far we've been just issuing curl requests directly to our backend, and there haven't been any headers on it. I haven't had to log in. I can just hit my hit the ingress and get a response. So we obviously would never do something like this in production. We want to have some type of authentication in our backend API. And for this workshop, we have chosen to use JSON Web Tokens. OWASP actually has this really scary stat of like all of these broken applications out in the wild. I don't know. Hard to imagine that 94%, that just seems ridiculously high, but it can be a problem. So a JWT is very simple. It's just a JSON string that gets encoded and signed. It's signed by a secret that the server knows, and then when the server gets that string, encoded string back, it can tell, is this something that I created or not, a token that I issued or not. And so this means that I know that the person making this request is someone I have decided should be authorized to make the request. It also has in its place, in its standard, a data payload. So I can actually put pieces of information in my token that is being used for authentication. There's some standard fields, like sub stands for subject. Typically that's who is going to be the person, like I will have some kind of client identifier, like a user ID. There's an expiration date I can put in there. So if I say this token should only be valid for a couple hours, I set the expiration date or the expiration time plus 2 hours in the future. And then, like I said, it's signed. There's going to be a signature that uses my secret string to validate that I issued this token. And that gives me an opportunity to reject anyone who is trying to make requests to my backend that I have not allowed them to. This gets passed in a request header. There's something called an authorization header that is standard to HTTP. It includes, as its value, the word bearer, and then something like this long string. And my application is going to pick that up. So we're going to actually put this into our backend API ourselves. It's one of the nice things about just using a header value that we can validate is an authenticated client, is that we don't need tons of libraries or code. There are other standards, like OAuth is another pretty common standard. It's a little bit more complicated where there's a couple different stages to OAuth authentication. And JWT just basically says, is this header present, and does this header have a token in it that I've signed? And so that means it's pretty simple for us as a developer to put this in our Express application from day one. So we're going to use a library to actually generate the tokens. We're not going to do all the encoding and signing code ourselves. So there's an additional library that we're going to add called JSON Web Token. And then we've pre-configured the application to have a token secret, but this is going to be what we use to sign. This is going to be something that the server only knows, and it is going to be injected as an environment variable. So it's coming from like a secret store or someplace else where we can store very sensitive values in our infrastructure, and then our application is just going to load it out of the environment and be able to reference it. So we're adding an endpoint here that will allow the backend to generate a token. So first, we need a way to create these tokens that are signed by our secret that then we can use for other applications to have an authenticated method to call our API. And this library gives us a signing function. And all we're passing to it is the data payload that we want included, encoded into that token. So if we want to have a username or a user ID, something non-sensitive that we can pass back to identify the user, we're going to include that in the data payload. And this is going to sign that token and return it as a JSON response. So if you've been able to make these code changes, you can test this out. Just go ahead and redeploy the API. And when that's done, you should be able to post to our backend. This is going through our API gateway. This is hitting our Express backend. And it is returning, as a response, a JSON object with a token in it. And if you actually take that token out, and you go over to JWT, and put it in there, here's my username as the subject. So I can see that this blob of strings has the data payload. If you even read your secret, you can put the signature in here. It's going to be a little extra work. There's a couple caveats I want to make sure you understand about JWTs. One is that, as you can see, they're not secure, right? Like anybody can grab this and actually read the data out of it. So it's not a place that's suitable to put really sensitive information. Like you want to put names, or sometimes some people also discourage even putting emails in there. So that's not a great use of JWTs. The other thing is that you can't revoke them, right? Like I've signed the secret, I've given it to my application, and until it expires, it's going to be valid. So if you do use this and you want to be able to, maybe you have a customer calls you up frantically, says, oh my gosh, we accidentally committed our token into a source repository, we think someone's going to find it. You're going to want to have on the backend side a way to revoke them. Sometimes that's just as simple as let's keep a list of tokens we want to reject, or audiences or subjects that we want to reject. And for the next 6 hours, we're just going to reject all those tokens until it expires, and they can issue a new one. But other than that, it's a great method to use for authentication. And so let's add in some code that's actually going to let us authenticate this. So here we're adding a new JavaScript file. This is not in the repo. And this is going to create Express middleware. So this is a function that we can use across all of the routes in our Express app. And it's going to look for an authorization header. And it's going to extract that header. If the header is not present, we're just going to go ahead and say 401, this is denied, right? We're requiring that you need to have a header to exercise this route. And then we're also going to verify it. And so our library comes again with this function that lets us pass that token secret in. So this is what we use to generate the token. And then match that with a given token, and if it's valid or not. And if it's valid, it's going to pass through without errors. We're actually going to attach the data of that token into our requests so that other things downstream can read that user ID out of it. So maybe your backend method actually wants to look up something by the user ID. Well, you can just pass that user ID as part of their authentication rather than have that as a request parameter. So we can export this method out of our auth.js and start to use it in our routes. So here's an example of our users endpoint. Our app has a bunch of information about users. And we can import that authenticate method. And Express makes it really easy to start to chain these middleware functions together. We simply change our route that was serving users / and we add the authenticate method into that method signature. And this is how Express will say, OK, I need to first pass the request response next objects to this middleware function. And then if that has a response and return for that function, I'm going to short circuit. I'm not even going to call this provided backend function that is listing all the users, making a request into my database and look. So it just will short circuit. And then if this does pass through the authenticate without a problem, then it will execute the custom logic for an individual backend. And you can see what we're doing in these user routes. Not a ton of magic. We're calling our backend. Oh, let's find an individual user. Let's find all the users. Let's return this as a status. And so here, this method, this implementation of this endpoint doesn't need to worry about, is there a valid header? Does that header have the right permissions in it? Anything like that. We can handle that all in a single middleware function. And all we need to worry about when this route runs is the happy path, which is great. This code stays very simple. So if you've been following along, you can add that middleware to some or all of the routes, run a deploy. And now if we actually run the curl to that user's endpoint, this should be listing all the users, we're going to get a 401 unauthorized. So that's an indication that our middleware is working correctly. The header is missing of this request. I'm not passing any custom headers in. And so because that token is not in the header request, we reject that at our application level. The next thing we can do is, then finally, we haven't put anything in front of the thing that generates tokens. That's problematic. We don't want anyone to be actually issuing requests to just get a token for themselves. So we're, in the workshop, creating a second authentication method. You won't have a token, so we can't use a token to get a token. We need another way to kind of get to the token generation endpoint. And so here, we're actually going to use our token secret as the header value. And if we pass the token secret to our endpoint, we'll get a JWT token back for all the other endpoints. Now, this is really just for the purpose of this exercise. You wouldn't want to leave your token endpoint unprotected, but you probably want to reuse a token secret that is really supposed to be just known by your server. In the real world, you would probably have like a password login. Maybe you would have a console where your users can log in and generate an API key for themselves. And this method then would be authenticated with username and login password. We're going to skip some of the complexity of setting up username and login. There's a lot of great libraries out there, like Auth0 or Propel. I don't know, there's a bunch of new ones that will let you just kind of drop in password authentication into your app. It's a little outside of scope here. So now, again, we're creating a very specific middleware just for our token endpoint. And we've added that to require the token secret passed in as a header. So if you're following along, you can deploy the API at this point. And then how do you get that secret? Well, we've stored it in Kubernetes secrets. And so if you use this command, you can actually read the secret that has been generated out of the Kubernetes secret store and pass that as a header to the curl request of the token endpoint. So you should be able to copy this command and run that and get a token back. Now that token then is something you can use to call your user's endpoint. So the token that we're generating, we're now using for the other API endpoints, also as a bearer token. And you would just copy that and paste it here. And now you should get a list of users from /users and a 200 response. You can see that we have a lot of information about our users in here. Email addresses, names. There's even a password hash coming back. Credit card numbers. We're going to work towards making this also a little bit more secure, but this is a pretty good example of what a simple list users REST command might be. All right. So we have authentication in place. I need a token to call any endpoint of my API. I need a very special token to generate tokens. And now if anybody is just hitting my API, they're probably going to get unauthorized without a valid secret. That's called authentication. We're not differentiating anything about that token as to whether it should be or shouldn't be allowed. If you have a valid token, you're able to hit any endpoint in our API. The next step what we want to do is add authorization. And so this is where we're going to introduce the idea that only certain tokens should be able to hit only certain endpoints of our API. So maybe I have a couple different personas of clients among my customers. Maybe there's a normal user that can read some of the data but not all of it. Maybe there's an administrative user that can actually modify the permissions. Maybe I want a read-only user. Like this user should only be able to read things but not modify them. How do I start to permission individual endpoints? Well, I could create a lot of different types of tokens that all have different types of secrets. That's really hard to manage. So you're going to lose track of which token secret is for which token. How do I make sure that they're using the right token with the right secret? So what's better is to add authorization. And we're going to do this by encoding extra information in their token. We're actually going to encode a list of permissions in the data payload for their JWT token. JWT does not really define a standard for authorization, so you end up kind of coming up with your own nomenclature. Here we've just kind of created this extra key in the claim, scoped by our domain. Some other schemes like OAuth does have the notion of scopes, and scopes are going to limit what can I use an OAuth token for. But for JWT, we need to kind of define our own. And so we're going to create an array of strings that are just going to correspond to different permissions. And we can come up with however structure we want.
Is it important to namespace it like that if it's something particular for you, or is it, can you reuse or whatever names? I'm just wondering, do you run into collisions with, if you call it scopes instead, would that be a problem? Or
yeah, so the question was about naming the permissions and whether it should be named permissions or the actual key for it. Yeah. So it is in the RFC that you should use a URL that's specific to your application, so generally domain you control. But as far as calling it /permissions, that's pretty arbitrary. This is using a list where it'll be read user in the list. Another common way of doing it is you would do jumpwire.io/user and have read as the value. But it's pretty arbitrary. Yep.
So we're going to add a separate method for authorization. So we're going to leave authenticate as it is. It's nice and simple. It's just validating that the token is there and that it's a valid token. Then we're going to create a second method called authorize. This looks a little bit different because it's going to take a parameter. It's actually going to take a parameter indicating what permission should the user have to invoke this method. And the way to do that with Express middleware is you wrap the middleware function with a function that takes a parameter because you cannot modify the parameters of the middleware functions. Those are defined by Express. So we're going to wrap this that returns the function, takes the permission. At this point, I'm going to read the user out of the request. If you recall, In the authenticate method, I was putting the JWT data payload into the request so that it would get passed down to other middlewares. So I don't need to worry about the structure of the token or decode it at this point. I'm just looking that a user object is in that request. And if the user object is there, that indicates that the token has been decoded. And then, of course, the user must have this specific property of its object. And then it should include the permission that is being passed in as a parameter. And so this is going to let me define granular permissions for each of my endpoints. If that does not, if I do not meet this strict case, I'm going to immediately return a 403. 403 is the HTTP code for unauthorized, forbidden. And that will short circuit. And then we will export this method from our auth.js. So all of our auth handling is in this one simple file that I can import into any of my routes. And so here's kind of an example of how I might use this in my users' routes. So you'll recall before we had added the authenticate middleware. Now we're going to also take in this authorize. You'll see when I add this middleware, it is a little bit different. I'm invoking this function, and that's because I'm passing in the permission that is required to execute this endpoint. So I expect that there's this read user string in the token in that array of permissions. It's just going to use string equality. It's going to look to see that this string is in the array of strings. And if it is, it'll then execute the route method. And you can see this now allows me to kind of set up two different levels of permission. Anything that is a post, a put, a delete, it's going to be modifying our user. It requires this permission modify. Anything that is just getting and reading information, it just needs that read. And when I generate my token, I can decide what permissions am I going to pass in. So we can start by actually passing in an empty array here. This will generate a token that has no permissions. And so before, I had a token and I could read users. Now if I generate a token with no permissions, I'm no longer able to read any of my users. I get a 403 response. If I generate this token with these strings in here, and these are strings inside of strings inside of strings, so it's a little bit down the rabbit hole, but essentially I'm creating an array that has both read user and modify user as strings in that array. I'm going to get a new token back, and now if I use that as my bearer token, I will get back all of my users. And that's it. That's pretty simple. Again, we'd be probably generating tokens slightly differently than this. It'd probably be in some kind of admin-controlled console where the admin decides what permissions should I be giving to different clients or different users. And so he'd have options to include permissions in his token. But for this exercise, we're just doing it here through the parameters of the token endpoint. So now all of our endpoints in our Express app require authentic token, and that token must contain permissions in it. Now you'll recall we had a background job that was running on cron. It was calling our Express server to get information about users and doing some logic on it, reconciliation logic. If you've been following along and you expect your pods, you'll probably see that that pod is in a crash loop backoff, which means something's going wrong with our reconciler. And we expect this because our reconciler does not have a token in it. It was just making HTTP requests to /API. We can fix that. So we're going to create another Kubernetes secret. We're going to generate a token. This is like us as the admin generating a token for a client or for an app that we want to use. So again, we're going to use our root secret to call the token endpoint. It's going to generate a token with these permissions in it. And then we're going to take that value and add it as another kube secret. So here again, we're putting secret values back into Kubernetes. And the reason we can do this is because Kubernetes provides us this really nice abstraction to inject secrets into apps. We don't need to put this secret in a configuration file that goes into source control and gets deployed with the app, or in a Docker Compose file. This is all going to happen at runtime. Highly recommend that you use a secret store in all your applications. Kubernetes ships with a default one. It's OK. But what's really powerful about it is that it is a consistent interface to a lot of other secret stores. So if you've heard of HashiCorp Vault or AWS KMS. Those are also secret store utilities that can be plugged into your Kubernetes secret store, and you can have them as backends for your secrets. So it allows us to use a consistent front end, Kubernetes secret stores for a lot of different implementations of backend secret stores. So it's a great place to put a JWT for an app that needs to call our newly authenticated backend API. So if you can bear with editing Rust, we have some examples of how we are going to read this token from our backend. Here, when we build a client, we're passing the token in. So this is being read out of the environment. We'll see that further down. And then it is adding a header to the requests that it is making to the API. So we need that header with the bearer space token in it. And that is where we are putting it here. There's some standardization around header values that we can reference. And now we have an HTTP client that is using an authorization header that has that token in it. We'll use that client when we are calling to get user IDs or transactions. And then here you can see we're reading it out of the environment through the configuration. So very clean abstraction. I don't have secrets in my code. My code just expects there to be a runtime that has these valid secrets or values in it. And now my application can use it. And if you read, so here's an example of where we are actually injecting that secret into the runtime. This is the chart for our backend reconciler job. And Kubernetes lets you just have environments that come from secrets. Here are static environment values. These are not sensitive, so we're just happy to have them in the chart itself. Here we're going to read a secret from an environment value, an environment variable from a secret value. And you'll notice that reconciler secrets as the name is what we used when we created the secret here, reconciler secrets. Inside that secret, there's a key value pair called app token, and the configuration is handling the mapping of that for us. So if everything has worked, we can redeploy our reconciler app, and the next time it runs, we should see it succeed. You'll just see the pod there. I might have an example of it. I don't have an example of it. Now, in a lot of cases, it's tempting to put authentication in place and come back to authorization. We're like, well, we really only have, one role in our API right now. Do we need authorization? I don't, it seems silly to give all of our tokens the same scope. It's a waste of work. And it's something that we really recommend putting in early because in a lot of cases, this doesn't become a problem until you do have enough complexity that you do want to limit who can access what endpoints or who can perform what functions in my front-end app. And in that, when you get to that point, like the product has decided, oh, it's really important that only admins see these pages, it's going to represent a much larger refactoring to put authorization in place because you kind of then need to go and back and put all this middleware infrastructure. And so the nice thing about just having this as part of our token from the beginning is we have that baseline covered, and then adding additional permission scopes is really just adding like those extra strings that we're going to use to delineate which endpoints shouldn't or shouldn't be allowed. And so even putting like an authorization with a star as the string, and everything gets a star string by default, it's all hard-coded, is a big advantage to trying to back into that later when there's a lot more complexity in the app. Maybe you have multiple applications that are serving different parts of your app. You have an API and a front end, and then you need to add authorization across the board. So what have we done so far? We've put in some infrastructure that is providing us protection against the big bad internet called our API gateway. We have some controls in there so that bad people can't do bad things for us, and it's a baseline that we can build on top of. We've added authentication authorization to our app, so now not anybody can just hit our endpoints. If they reverse engineer our URLs, they're not going to read all of our data. those have all happened kind of at the application level. The next category we're going to address is cryptographic failures. So we're going to start to encrypt traffic. If you've been following along or you've noticed in the examples, we've just been using HTTP to make requests to our backend. What this actually means is that all of that information in that request and response is coming across the network unencrypted. And so if someone can read the data on the network, they can read all of my user information. And how does someone read data off the network? Well, we're all on Wi-Fi right now, which means all of our network is actually radio waves in the air that anybody can read. Really, really insecure. Fortunately, for HTTP and encrypting HTTP using HTTPS, there's been a lot of advancement over the last 20 years to make this a hard requirement. If you're exposing an endpoint, HTTP endpoint to the web, there are going to be things that are going to break if you don't have HTTPS. In particular, browsers. Browsers will throw up a big warning. Maybe you've gotten it. This seems like a malicious site. Are you sure you want to proceed? It's because it's unencrypted. Google search devalues things in its ranking, sites in its ranking that aren't using HTTPS. When I kind of started my career, Facebook was this new company that launched. It initially served traffic over HTTP, and it was kind of fun to sit in a cafe and read people's Facebook friends profile because you could just sniff the traffic off of the internet. That's not as easy to do anymore, but it's still important that we have encryption in place for data traveling across untrusted networks. And the internet is big untrusted. Private networks like our Wi-Fi network is untrusted, and so it's very likely that you're on an untrusted network today. This is number 2 on the OWASP, and there's a lot in cryptography. It is a very deep subject. I myself am not the cryptography expert, that's William, but I think that it is actually not as hard as it used to be to start to set some of this up yourself and put encryption in place into your cluster and into the communication that is happening around your application. So we're going to start to this with Kubernetes Cert Manager. This is a custom resource inside Kubernetes that is going to just kind of make it easy to issue certificates. So the way the encryption is going to work is usually there's a public-private key. The public key encrypts, the private key decrypts, and every application should have its own set of certificates that it's going to use to encrypt traffic. The client can also validate that it's talking to a host because the host is presenting a certificate, and we can say, oh, this is a valid certificate coming from our host because the certificate authority matches the signature. And we'll see some examples of that. But the Cert Manager is a nice utility for us to not to need to get into the nitty-gritty of actually generating all of our own keys. We are going to generate one key. And this is where I get really tripped up anytime I'm trying to use OpenSSL or other certificate utilities. I always have to do a lot of Googling because I never remember what all the different algorithms mean and the commands and things. So we are going to generate one certificate. We're actually going to generate the certificate authority ourselves. The certificate authority is a set of certificates that typically get distributed with your operating system. And these are very super secret certificates that only a few people in the entire world can generate, but they can be used to validate the server side. So when I send a request to Facebook and it sends me a response, Facebook has generated certificates from a known certificate authority that is also in my computer, and so I know that the certificate of the response has been encoded correctly. Now, because we've been doing everything over localhost, localhost is not a domain that you can go to on the internet. And all certificate authorities and any certificates you generate for HTTPS traffic traveling over the internet is tied to a domain. It's only valid for a certain domain. We don't have that ability to do a domain in this workshop, so we're going to actually generate our own certificate authority that is valid for the localhost domain. And we're going to install that in our root system so that then we can make authenticated requests into our cluster. And so if you installed makecert, this utility, and you run this command, this is actually putting a CA into your local system. So you're going to notice that we use this command further on. This is basically saying, where's the path to the certificate authority keys on my local host so that I can use this certificate authority in other places in my infrastructure. So the first thing we're going to do is create a key pair. Again, this is the public and private key for certificate authority. I'm going to use that and create a secret in Kubernetes. So this is me loading those certificates into Kubernetes as a secret that I'll be able to then reference for all of my backend services, my API gateways, to also use the certificate authority. So we're creating one secret that's going to contain both the public and the private key, so we can generate certificates. And then I'm going to create another secret, which is going to be just the public key, so that I can use this to validate responses that I'm getting back. Not every service needs to generate its own certificates. If I'm just on the client, I'm making a client request, and I'm validating a response, I only need the public key. Next, there's a chart that we can apply that's actually going to configure our cluster issuer with this root certificate. So again, up above, we installed Cert Manager. Cert Manager is going to use our cluster issuer, and this is going to be able to allow Kubernetes to create certificates using our root certificate. Now we want to generate a new certificate for our API gateway. So requests are coming from my client, my local host. They're passing through my API gateway. That's the first backend endpoint. Then the API gateway is forwarding that request to my Express API backend application. And so if I want to communicate with the API gateway over HTTPS, the first leg of that request, I need my gateway to have its own set of certificates that I can validate against. So we're going to run this command that is just basically going to use our cluster issuer to generate a set of certificates for our gateway, which is the Kubernetes ingress. And then I can update our gateway to use web secure. So web secure, this is traffic nomenclature. This is not common. But basically, this is saying stop serving HTTP requests on port 80. Start only serving HTTPS requests on port 443. And it's mapped to port 9443. So 443 is kind of a designation of a HTTPS, and 9443 is just the port that we're port forwarding locally. And then we give it the name of that secret that we created. So again, we created a secret that will have certificates in it that our ingress can use. Those certificates are signed by that root CA that we generated locally on our machine. So our machine has that root CA, and now we're giving our API gateway a set of certificates to use that are also generated by that CA. Now you'll notice we're still forwarding ports to the backend. Don't worry, we'll fix that. But we're porting just HTTP requests to the backend. So we apply this to our gateway. So we update our gateway to start using HTTPS. And now if we make an HTTPS request to backend API, you should see, oh, well, here is the server certificate, and it's been validated. And this was the root CA subject that we used. So we came up with our own. Again, we were defining our own. And that CA is valid for localhost. So the host, which is localhost, is matching the certificate. And that allows our client to accept that request. It's returning a 404, that's fine. But this is HTTPS is valid. And if you tried to use this and it wasn't valid, you will not receive a 404 response. curl will actually just error out and not show you the response because we're not able to validate the certificate on the server side. So that wasn't too hard. And again, I think it's pretty common for you to set up in your local dev, just use HTTP. Or I found this thing, skip verify online. I'm going to use that. And I strongly recommend to just go through the steps of setting up HTTPS in your local environment. And hopefully this showed you it's not super difficult. You do need to generate some certificates and have them on your machine. But once you do that, you can start operating in HTTPS. And one of the benefits there is I've lived through a lot of examples where it works on my machine, and then I go and deploy it, and there's actually something wrong with the TLS, or it's not configured or something, and you won't find that until you're in a kind of a stage in your production environment. And then it's impossible to debug because you can't reproduce it locally. So if you do just a little bit of effort to install HTTPS locally, there's a lot of benefits. Now, I'll also say people sometimes stop here. They only put HTTPS on their gateway, on the thing that's taking that first leg of the HTTP request. And then everything after that, they're fine leaving HTTP because, oh, it's inside my private network now. Do I really need it encrypted? It's called TLS termination on the edge. It's still pretty widely used technique today. But because this is a security workshop, we actually want to do better. And there's some auditors out there, I'll say there are very few, but there are some auditors out there that will take a look at this setup and say, hey, wait a minute. All that traffic going between your gateway and your Express microservices is unencrypted. You said you were doing everything encrypted in transit. And here's an example where you're not doing that. I'm going to flag this as a finding. So it could come up in an audit. But it's also just a good hygiene to have encryption everywhere. Even inside my Kubernetes cluster, requests being made across that virtual network inside Kubernetes, I want that to be encrypted too. And it's not that hard. Because just like I generated a certificate for my API, I also can, for my gateway, I can also generate a certificate for my API. So we're just going to run this again. It's going to create a secret that has a key pair in it. And then I can load this key pair into my API backend. So first, I'm updating the port that I listen on. I'm no longer going to be serving on port 80, which is unencrypted. I'm going to serve on port 443, which is encrypted. I need to load these certificates as volumes into my pod because they are stored on disk. The Express application is going to search for these certificates off of the disk. So instead of injecting that secret as like an environment variable, I'm actually going to inject it as a volume that I can read from off of the disk. So you can see that I'm adding these volume mounts. And then when I start up my code, here I'm going to change my server to use HTTPS. I need to be able to read off of my file system. And I can create an HTTPS server by just using that cert directory, and the keys of my secret will be on this path on my file system. And now I have HTTPS being served out of my REST API. So what this means is then, even though my REST API cannot be hit directly from the internet, it is serving requests coming from my ingress, my gateway. So I do need to tell my gateway, okay, when I call my backend service, also use HTTPS. It's not the default. But I can add in an annotation. This is, again, coming from traffic. This may vary by gateway, but traffic has this custom resource called a transport. I can tell it, okay, now traffic here is my client. I want traffic to use HTTPS to talk to the backend service and validate that it's a valid certificate being served from my server. So I need to give it my authority key. This is the public key of the root CA that I generated, so that when it makes a call to my backend using a key signed by that, generated from that root CA, it can validate it. And then when I call my backend, I'm no longer going to call it on port 80. I'm going to call it on port 443. And I use this transport configuration to validate the TLS. And so now I have a full encryption end-to-end on HTTP. I have my client, my local host, calling the gateway with HTTPS. The gateway has a certificate that my client can validate. And then the gateway is making a call to my backend API, also using HTTPS. And it also has a certificate that it can validate because we're using the same certificate authority. And now I have full end-to-end encryption in transit. Sure.
There's 2 ways.
Yep.
And are you reusing the same certificates?
So-
One second, like this.
So the question is, there's 2 legs to this request. Are we using the same certificates? No, we are not. The first leg has the API gateway has its certificate. The second leg, the Express API, has a different certificate. But they are all using the same certificate authority, which was this root CA cert that I generated. And so when the second leg, the API gateway, is making a request, it is validating that the Express server has used a certificate signed by that authority. Because right up here, I'm telling it what authority should it use to validate requests going to backend services. And so because I have the same authority, then when the first leg of that response comes back from the API gateway, from the Express API to the API gateway can validate that it was properly served over HTTPS. And then when I get a response back from the API gateway, I see the API gateway certificate was also signed with a known root authority.
Is it important for those to be two different certificates? I would think that would be important.
It is important. It would work if you use the same, but in general, it's just a best practice to generate service-specific certificates. It allows you to roll them. So maybe you actually want to renew them at different time frames, and so you'll have independence to be able to do that as well. And certainly if one gets exposed, you're able to very quickly replace it without replacing every certificate in your cluster. And certificate problems can take down entire clusters in applications. So having a little bit more granularity over that, where one certificate expiration isn't going to mean you take everything offline, is super helpful.
Another thing to think about there is if you do have a bunch of backend services, you might need to have the API gateway have like a star certificate, a wildcard, but then each of the backend apps could have a certificate just for their own domain. So you could have an API dot, a legacy API, and a new API with 3 different certificates, and then the API gateway would have either all 3 of those in, or just have a wildcard so that it could route to anywhere in your backend. A little bit. This gets very Kubernetes specific, but the cert manager is going to update the secret. So depending on the application code, it may or may not realize that there's a new certificate to look at. But when the secret gets updated, Kubernetes will update it on the disk, and then it's up to the application to figure out like this file has actually changed under it.
So we have someone else still making HTTP requests in here. It's the reconciler. I'm going to skip this, but there's instructions on how to also give the reconcilers, to load the root CA into the reconciler so that the reconciler can also validate requests it's making to the API backend. Again, you see we're reusing that secret that has the public key of the root CA in it for the reconciler, so we don't need to generate a reconciler its own certificates because it's not serving requests, it's only making requests. So, everything's encrypted in transit, right?
No.
No! There's still one leg, and that is information going from my API server to my database. And you might think in this day and age, oh, of course, databases are encrypted by default. They're not. They have their own protocol. It's not HTTP, but it is still an unencrypted connection by default, most of the time. I'm sure there's modern ones out there that are now catching up. But if you just roll up RDS with Postgres, it's probably not going to have encryption set up. And furthermore, for a database like Postgres, it is up to the client to say, I want to use encryption, unless Postgres has been specifically configured to only require encryption, which is not the default, because most of the time they just want to make sure clients can connect, not have a problem. So we have some information in here to also generate a certificate for Postgres and start to use that. So we're going to create a new secret called Postgres TLS. Again, we're generating a key pair specifically for Postgres again. We're not reusing them. We're mounting it as a volume so that Postgres knows where it is and can load it up. And then when we come over to our Express server, we are going to pass in a special configuration that says, use SSL, and here's the certificate to use when you're creating a connection to Postgres. Now we can apply these changes. Now we can say all the legs of information passing over the network is encrypted. This is really awesome. There's nowhere where information is moving unencrypted. So we're going to spend the last little bit here talking about Jumpwire, and then we'll wrap up. Both William and I are going to be here for the remainder of the conference. If you see us in the halls and you have some questions, you're like, oh, I was trying to run this workshop offline, it didn't work, help me out. Happy to do that. But what is Jumpwire? You don't know what Jumpwire is, very likely, because we're kind of a new company. And we're building a product that is kind of a new category. And what Jumpwire is, in a nutshell, is a gateway for a database. So you'll remember at the beginning of the workshop, we set up an API gateway to handle HTTP requests coming into our cluster. Well, what about SQL queries that are running in our database? What is controlling those SQL queries that are accessing data? And what is saying that this query should be able to access this type of information for this client? There is authentication that you can put into your database. Usually you're signing in with a username and password. Sometimes you may go as far as allowing certain clients to only read, so they can't modify data. But if you want to get really granular about this client should not be able to read customer-sensitive info, you're not going to have that capability natively in your database. And that is what Jumpwire provides. We intercept all the SQL queries that are being run, and we inspect to see whether they are trying to access data that they are authorized to access or not. And we give you, as application developers, control over what backend should actually be able to read credit card numbers out of my users database. Should any backend that can connect to the users table and query the users table read credit card numbers? Or should there be a special designation that you can read a credit card number out of that? And this can help mitigate the risk of a data leak. A lot of data leaks happen by people dumping databases. And that's because they're able to compromise an application that can run arbitrary queries against a database. It can also give you features like, how do I let my engineers access production database, but ensure that they're not reading customer-sensitive information like social security numbers? Maybe I want to give them a set of credentials that they can use. So it's kind of a lot of different gateway capabilities, but it's in the database realm. And we think that this is important because a lot more things are connecting to our databases in production environments than they used to be 10, 15 years ago. It used to be maybe there was a REST API in front of a database. Today, I probably have internal tools that connect to my database. I may dump my database into a data lake, or maybe I have ETL processes that are taking data, munging it up, and putting it back in the database. And so there's just not as much isolation that you get by having a database just sitting on its own in your internal environment. And you probably want a way to control how information is moving inside and outside of that database. And again, we've worked hard to make Jumpwire quite simple, just as easy as it was to deploy that API gateway. We talk in the database protocol, so just like the API gateway talks the HTTP protocol. My browser can connect to it, and it understands how to issue requests to the API gateway. We can talk individual database protocols, and that allows my application to just connect to Jumpwire instead of connect directly to Postgres, and it start issuing requests without any modifications. So we have some examples in here of how to set up Jumpwire. You do generate some secrets for Jumpwire to use. Certainly, it's going to need its own TLS certificates because it is using encrypted connections between the client and Jumpwire in the database. And then we've already configured the application that's being deployed in here to label specific fields. And if we go and we actually look at Jumpwire's configuration, it introduces a level of abstraction on top of your database schema so that you don't need to say, oh, William is able to read the column named social security number, but Ryan is not. Instead, you say, well, social security numbers in general are PII, and William can read PII and Ryan cannot. So similar to how our gateway gave us some level of abstraction over how to route requests, we give you a level of abstraction on how to authorize queries. And if I'm not authorized to read social security numbers, if I try to query a column named social SSN or social security number or in any derivatives of how that column might be named, my query is going to fail. And when we have this notion of policies, and it's not all about does the request succeed or not, we also offer encryption. So we can ensure that PCI data actually remains encrypted if it ever leaves the database. You might know that PCI is a standard that has very strict rules around where a credit card number can appear in an unencrypted form. And one feature of Jumpwire is, well, that should always be decrypted when it leaves the encrypted when it leaves the database. And the only designated applications or individuals should be able to read a decrypted credit card. And so Jumpwire can see a column labeled PCI and apply this policy called encryption. And then the last policy that we're creating is to drop secrets. So we don't think there's ever a scenario where the password hash should be leaving the database. You might have noticed password hash was part of the user that was being returned in the user's object at the very beginning. We never need to expose password hashes. Nothing should be able to need to read it except the auth server. So in general, we're just going to drop that out of the SQL request. And what Jumpwire will do, we'll simply null out that column. In this case, the query will succeed, but it will just have an empty value for that password hash. So if you follow along and actually made it through keeping up with this rapid clip, we can deploy Jumpwire. We need to generate credentials because now there is authentication happening between our Express app and Jumpwire, and that is a username and password that it is going to use instead of the database's username and password. So we're generating credentials for our Express app as a client. We go ahead and actually load those as a secret as well. We're cleaning up a little bit here where you might have noticed we had a database password in a Kubernetes chart before that was committed into source control. Not so great, so let's actually just use the secret instead. And we're going to use the credentials that Jumpwire is generating. And now when we make that request, this object looks a little different. So instead of something that looks like a credit card, we get this really big encrypted blob. This is Jumpwire encrypting that credit card number. And then password hash is actually null. It's not being returned. So we think that this is a fairly handy tool. Again, we're a relatively new company working in a relatively new category of database gateways.
And it's enterprise only, right?
No, we are completely open source. We do have some enterprise features like auditing and integrations into identity providers, but the vast majority of our functionality, including everything you see here, is in the open source package. Yep. So the question was, what is the maturity or stage or profile of a customer? We find smaller companies with engineering teams that may own the database interested in access controls. So typically they are trying to solve for, well, there's a lot of situations where I need to let my engineering team into production, usually to debug an incident. How do I do that without exposing all my data? And so that's great for our community version, our open source version. They can put an appliance in place. Maybe they're not doing all the advanced encryption, but they do want a way to control how people, individuals in their organization access it. And then when you get to a larger enterprise, typically they are a bigger company, and they are interested in things like auditing because they need to have an audit log of all the queries that are requesting sensitive data because they turn over that audit log to their auditors. And so that's an area where they would come to us and ask for some extra support and enterprise features.
We think of it a lot like the API gateway, where getting it in early is a fairly easy change to make, and then it can kind of grow with your application, with your infrastructure, rather than trying to go back and refactor 100 microservices to all have limited permissions, which is much harder.
It's a great point. On the other hand, of course, you never do something unless you have to do something, because the risk of getting it done wrong
For sure.
Yeah.
is quite high. So I think part of the value here is that you adhere to best practices, right? Because oftentimes you're just doing the doing.
Right.
Yep.
Oftentimes best practices is as valuable as the technology.
Yep, that's right. And we see, a lot of companies, especially fintechs, getting like a SOC 2 fairly early on. SOC 2 puts a ton of emphasis on the access controls. And so there may be cases where they are motivated to not just give username and passwords to the production database to their engineers, and they want to have a more formal method for generating credentials and managing production level access for a SOC 2 audit, even if they're a 40, 60-person company.
Yeah, that's sort of where it comes into like, these are security controls that need to be put in place no matter what, because the auditors are requiring it. But it's really hard to do, or really hard to manage as you scale up a team, right? So something like Jumpwire can come in and just make it easier. But like you said, you're not going to care about that security unless there's an external reason to care about that security.
I might have missed you saying this a minute ago, but the credit card there, you were saying that you shouldn't send that credit card number back decrypted. Or didn't say you're encrypting it here. Are they storing it decrypted?
It's optional, but yes, it can be stored decrypted and then encrypted on the fly as the responses go through Jumpwire, or it can be encrypted on disk as it's being inserted into the database.
All right, well, we have just a few minutes left. There are a couple more sections to the workshop. I encourage you to read them. Misconfiguration, so this is talking about some of the defaults of what your server might be configured. We wanted to put this in because this always gets flagged when you run your first penetration test. And there are some super simple, like we're just using, again, a node library to kind of turn off some of these leaky headers and things that a penetration tester loves to flag people on. And then, as we anticipated, we didn't get to monitoring, but knowing what's happening, in your production environment is half the battle. You want to kind of be aware, like, are there a lot of authentication failures all of a sudden that is much higher than the normal number of authentication failures we're getting? Okay, maybe someone's trying to brute force attack one of our endpoints. And so setting up aggregated logging is really nice. It's really hard to kind of go individually to each server and try to look at its individual logs. We show how we can very easily aggregate logs into Elastic and Kibana and set up some dashboards for us to kind of monitor the overall security health. So let's check our poll here. Well, there you go, majority Kubernetes. You're right.
Yep.
I owe you a drink. I wasn't sure how familiar the crowd would be with Kubernetes.
Nobody on Heroku.
No one on Heroku, which is great. And some render fans and Vercel fans. I loved Next.js a lot until recently, and now I'm not so in love with Next, but that's fine. Just a couple things to wrap us up on. We talked a lot about technical stuff, right? Like a lot of code, configuration, we were in source control and stuff. There are other things that you can do, even as developers, to encourage good security in the organization. And these are just practices or organization structures that you can do. So one is have a security review as a discrete step of creating a new piece of software or embarking on a large initiative. And so whatever your product process is, as early as possible, put some time aside to sit down and try to determine, okay, what could go wrong here from a security perspective? A lot of it is, let's look at the data that this new backend microservice is going to handle. Is some of it sensitive? If it's sensitive data, do we need to have extra requirements in here to make sure we're meeting our security standards? And it's just a nice way to kind of put a muscle, start training a muscle where you're thinking about security early in your software development practice. The other thing I've participated in is a security champion program. This is great for organizations that have a small security team and a large engineering team, and the security team is constantly swamped, and they can never respond to you on Slack when you have a security question. And so this lets the security team put out some kind of formal guidelines of, here's what we would love developers to know ahead of time. And we can designate one person on every Scrum team to be a security champion. And they're kind of going to be the ones that are looking out for these mistakes or these best practices are being done among the projects that they're participating in. And then the last one is tabletop exercises. This is really great for incidents. I try to introduce this very early on because there's always going to be a bug happen in production and everybody's going to freak out and the CEO is going to be blasting everyone on Slack of like, what the heck's going on? And everybody's really panicking. And a great way to lessen some of that panic, diminish it a bit, is to actually just run through an incident that's not real. And you'll have one person just kind of be the moderator there, and they are going to propose, oh, this happened. This just happened for our customer, or customer just said, hey, I can't reach this backend. Let's go. What happens next? And you get individuals in the room that are going to have important roles in managing an incident, and they're going to just kind of go through the incident response as if it was happening in real time. And what you end up realizing is, well, not everybody is really clear on their roles. Like, what is the CTO? What's the VPE? What's the customer success leads? What are they actually responsible for during an incident? And you kind of iron out all of those confusion, and it will make a real incident just run more smoothly without a lot of people talking over each other and a lot of confusion. There are also just like really low-hanging stuff you can put into a CI/CD pipeline that automates a lot of security. This is really around, am I accidentally committing passwords into my source control? You can actually have code scanners that will pick up on that. I think GitHub even has one today. And it's going to flag things before it gets moved into main branches. Same thing for CVEs. You're using a lot of libraries. Sometimes those libraries suddenly become vulnerable. This is especially true if you have a service that's been running great for a year. Well, it's also meant that there's been a year for people to find vulnerabilities in some of the libraries you're using. And so you can have a scanner that's constantly flagging your dependencies of all your apps and saying, hey, this new vulnerability was found, and there's a fix for it. You should go upgrade that dependency. And so you can just have that as part of your infrastructure as code, or as part of your CI/CD pipeline. If you do use infrastructure as code, so you're actually describing your infrastructure, there are things that will scan that code and say, hey, I'm creating an S3 bucket. It looks like it's unencrypted, or it looks like it has a public object settings. Are you sure that you really wanted objects in that bucket to be public? And can flag that before those infrastructure changes get applied. So really nice, takes a lot of the work off of individual engineering teams and automates it. So this is a quick recap of what we run through. I think the last thing we'll leave you with is there is no totally secure system out there. You should not feel bad when a vulnerability appears in your work, because that is going to happen. There are always new threats, always new vectors, and attackers are clever. And so what we've been trying to do is try to put baselines in place that let you easily upgrade or harden your application when some of those weaknesses are discovered, or they do become a priority even if they're not a priority today. Finally, if you'd like to find us, we'll be here in person. Our core community version, the open source version, is at this GitHub. It's a different organization name than we ran the workshop over, because we're always renaming stuff. We're online. And lastly, if you wouldn't mind rating us if you've downloaded the conference app, the organizers would love to see some ratings. And so would we. If you have some great feedback for us, please let us know. Hope you enjoyed this. It was a little bit of a sprint, but now you can go through the rest of the conference a little more relaxed, maybe sit up by the pool if you'd like some nice intense heat to sweat, and then jump in the pool and cool off. That's what we're going to do. And yeah, hope to see you around. Thank you all for attending.